Hello everyone, I'm Owen, and I'm going to talk about some parts of this robot, do some tutorial type things. I don't really have parts, so what I'm going to do is a little bit limited and based off what I have on here to begin with. So let's start with the drive. So this is my robot. As you can see, it's a 6-wheel drive. So some people have been saying, oh, 6-wheel drive can't get over the bump. You should definitely use a 4-wheel drive. Now, there's some truth to that. So if you have a 4-wheel drive, see, I'll show you this again. So that's in the second to lowest hole. Now, if you had a 4-wheel drive with the wheel where it is, you would not be able to get over the bump. You would bottom out. Now, what people are saying is you should use a 4-wheel drive that's raised to be a little bit lower, so you have like a pillow block there, and then the axle going through right there, and then that gets over the bump really well, which is true. That does get over the bump better than this. This takes a little bit longer. But there's also some advantages to having a 6-wheel drive over a 4-wheel drive. So this middle wheel is high traction. It's also a sprocket. So there's a high traction tire around a sprocket, which I think gives it a little bit more width over just a straight up high traction wheel, which makes it work better for a middle wheel, because otherwise it would have some less force on the ground, if it even had force on the ground. And so doing this way gets your center of gravity lower, because you can have your wheels sticking out less far on the ground, so you can have more channel closer to the ground, which lowers your center of gravity. It also gives you some resistance to getting pushed sideways. So there's my robot right there. If I try and push it, I can push it, but it has some oomph to it. Now on the tiles, it will be harder to push sideways, and the more weight you have, the harder it is to push sideways also. And this is not that heavy, but it's decently heavy. The base is all steel and the tower is all steel. The lift is all aluminum. And how I like to power the drive is this one has chain, obviously, but what I like to do is have motors directly on the wheels. So I like to put motors directly on the wheels in high-speed configuration, which is 1.6 to 1, but directly driven on the wheels. So the front and back, or the middle wheel has a motor directly on it, and the back wheel has a motor directly on it. So why I like to do that is if the chain breaks or something bad happens like that, it will still work. You won't be doomed. And that's great, because stuff always goes wrong. And this minimizes the damage. And then I also have another motor up above that's not on a wheel, and right there, and this is chained together with the other wheels and shares power. The front wheel needs to be powered in this year's game, because you need to be able to go over the bump, and the only way you can is if all wheels are powered. The other thing about this type of drive is you have to be kind of tricky with how you do a 6-motor drive, because often if you don't do it right, the middle wheel will go backwards, which is just not a good situation. You don't want your middle wheel going backwards. So you have to try a little bit experiment a little bit with how you have your tensioners and which way you run it around things. And it's best to have as few tensioners as possible, because each one adds friction, and the more friction you have, the less efficient your drive system is. And I think 1.6 to 1, which is direct drive, internal 393 high-speed gears, is the best median ratio in pretty much all games. You can go faster, but I think usually when you go faster, it's harder to control, and there's danger of stalling out. You can go slower, but if you're slower, you won't be able to score as quickly. I think 1.6 to 1 is just all around the best ratio, unless you have some like crazy specialty thing that will require a different ratio. But I think this is the best ratio for an efficiency robot. So, thanks. See ya.